The ninth part is f of x is equal to 5 plus 3x minus x cube. F of x is equal to 5 plus 3x minus x cube. Solution, we have function 5 plus 3x minus x cube, and the first derivative is 3 minus 3x square. Now second derivative is minus 6x. So for stationary points, put first derivative is equal to 0, which is 3 minus 3x square is equal to 0, and from this equation we will get the value of x. So by simplifying, x square is equal to 1 and x will become plus minus 1. Now we have two values of x, which is plus 1 and minus 1. So we check these two values one by one by putting it into the second derivative. So put x is equal to 1 in second derivative, we get minus 6, which is less than 0. So as we already know that if second derivative return a negative value or less than 0 value, then the given function has relative maxima at x is equal to 1. And for the maximum value of the function, put x is equal to 1 in given function f of x 5 plus 3x minus x cube. So f of 1 has 7, which is a maximum value of the given function. Now put second value, which is minus 1 in second derivative, we get a second derivative minus 6 into minus 1 plus 6, which is greater than 0. So f of x has a relative minima at x is equal to minus 1. And for the minimum value of the function, put this x is equal to minus 1 in given function. So f of x is equal to 5 plus 3x minus x cube. By putting it x is equal to minus 1, that will return 3, which is a minimum value of the given function. So function has maximum value 7 and minimum value 3. Question number 3. Find the maximum and minimum values of the function defined by the following equation occurring in the interval 0 to 2 pi. So we have defined domain or defined interval, which is 0 to 2 pi. A function is sin x plus cos x. Solution, f of x is equal to sin x plus cos x. Our first derivative is cos x, and the derivative of cos x is minus sin x, and the second derivative is a derivative of cos is minus sin and derivative of sin is cos. This minus will remain same. And for stationary points, put first derivative is equal to 0, and we have cos x minus sin x is equal to 0. And by solving this equation, we can write cos of x is equal to sin x. Dividing cos x on both sides, we have sin divided by cos and cos divided by cos, which is 1. So tan of x is equal to 1. Since tangent is positive in the first and third quadrant with reference angle pi by 4, as the given interval is 0 to 2 pi, which is this one. So as tangent x is equal to 1, which is a positive value, and we already know that tangent is positive in first quadrant and in third quadrant. This one is actually a trigonometric equation, and we already know just how to solve this equation, as we discussed in our first year. To finding the value of x, we have a reference angle pi by 4. So x is equal to pi by 4, which is in first quadrant, and to find the value in third quadrant, we have x is equal to pi plus pi by 4, which is 5 pi by 4. So we have two values, one is pi by 4 and other is 5 pi by 4. So now we put these two values one by one in second derivative. First put x is equal to pi by 4 in second derivative, we get f double dash pi by 4 minus sin pi by 4 minus cos pi by 4. So minus 1 over square root 2 minus 1 over square root 2, and by simplifying this by taking LCM, we have minus 2 divided by square root 2, and that is a negative value. Second derivative return a negative value, so the given function has relative maxima at x is equal to pi by 4. And for the maximum value of the function, we put x is equal to pi by 4 in our given function, which is sin x plus cos x. So f of pi by 4 is sin pi by 4 plus cos pi by 4. By simplifying, the value of sin pi by 4 is 1 over under root 2, and the value of cos pi by 4 is 1 over square root 2. By taking LCM, we have f pi by 4 2 divided by square root 2, which is actually this one is simplifying. Simply we have square root 2. Now we check our second value, which is 5 pi by 4, put in second derivative. So f double derivative 5 pi by 4 minus sin pi by 4 minus cos 5 pi by 4. 5 pi by 4 is actually third quadrant, and sine is negative in third quadrant. So the value of sine 5 pi by 4 is minus 1 over square root 2, and this minus will remain same. And similarly, cos 5 pi by 4 is also a negative in third quadrant, so will give value of minus 1 over square root 2. And by simplifying, this minus and minus will become plus 1 over square root 2 plus 1 over square root 2. And so second derivative is greater than 0. So f of x has a relative minima at x is equal to 5 pi by 4. And for the minimum value of the function, we put x is equal to 5 pi by 4 in our given function. So f 5 pi by 4 sin 5 pi by 4 plus cos 5 pi by 4. Sin 5 by 4 due to the in third quadrant will return a negative value, which is minus 1 over square root 2. And similarly, cos 5 pi by 4 is also in third quadrant, so will return a negative value, which is minus 1 over square root 2. By simplifying this one, taking LCM, we have minus 2 over square root 2. And just to simplify, that is minus square root 2, which is a minimum value of the given function.